various countries all over the world, and I think it's really great effort. So the story I'm going to share is mostly, it's not just a bunch of failures, it's more like a learning story, something you can learn from. And because imagine you're sailing the unknown sea and you can't find out what actually lies beneath the surface. So you need to rely on yourself, your ship, and your crew, just like in software engineering, when you have to rely on your team, the tools you use, some paradigms, and all of that in order to achieve the result. So let's embark on this journey. So I work as a big data developer at Captify, and I'm based in Kyiv, but our engineering department is divided between London and Kyiv. Also, I'm Women Who Code Kyiv data engineering lead for 3.5 years already, and I'm a huge Kubernetes and functional programming fan. So today I'm going to talk first of all on how to run Spark on top of Kubernetes. We'll talk a bit about Spark possible approaches to running it in the cluster mode for Kubernetes specific features. Also, I will share my personal experience of research stage of the project when we only started out, finding out how to work with that, and more like to the production stage as well, and we will draw some conclusions out of it. So fair warning in the beginning that the story I'm going to share is related to my previous experience at my previous workplace. And I used to work in this huge consulting company, one of the biggest in Ukraine, in the R&D department. So it's not like all the tools I use daily right now, but for me it was a very unique experience, and that's why I'm sharing it. So you may start asking question like, what big data engineers actually do? And I can't like give an answer in a very short sentence, but you can imagine that we kind of stand in the middle between DevOps infrastructure side and data science side, because we work a lot with data, we help to build pipelines, we help to deploy them, and all of that. So I think the better answer would be just to see our tech stack. So can you see the next slide or not yet? Oh, right now it's just been a delay, I guess. Yeah. So this is the tech stack that we use. Obviously, I don't have to work with all of it, only some set of tools, but you can see here that we work with streaming data processing, batch data processing, with data storage, building data warehouses, providing some data pipelines of various databases like relational, non-relational, all of that. And in the middle of this stack, there are Spark and Kubernetes. And again, a bit of a small delay. Yeah. So Spark is one of the most important tools in the big data ecosystem. Most of the projects are built on top of it. So it's like a must-know and must-have in most of the projects. While Kubernetes is more like a new one for big data world, and it has become quite popular in recent years, but still it's not something that most of the data engineers use. It seems like more from the DevOps side for a lot of them actually. So right now I'm going to talk more how to map this bridge between these tools. So when you have to run Spark application on the cluster, like not locally, you can choose various cluster managers like Yarn, Standalone, and Apache Mesos. This is like the usual choice. They have all of the different features, but mostly they help to manage the resources, schedule applications, and all of that. But since Spark 2.30, which was more than a year ago, In this version, Kubernetes was officially natively supported by Spark. So it was a huge community effort. A lot of people actually really wanted this to happen and felt like it was something important because we had to look for other approaches for usage of Spark on top of Kubernetes. And also, this event actually opens a lot of opportunities for those who want to extend existing native support and to build some more customized features. So in order to deploy something on Kubernetes, which is not just a framework, it's more like an ecosystem, you choose some kind of objects you want to use, like pods, deployments, and all of that. And I would say that one of the biggest challenges with Kubernetes for engineers who don't come with DevOps background is actually high learning curve. Because if you are even familiar with Docker images, with Docker containers, and you're aware of like the concept of containers itself, it's going to be really hard to find out like what object you would use for what purposes. So for instance, Kubernetes has an API, REST API with all of the objects. And here you can see the set of these objects like pods, deployments, replica sets. And you can imagine that you have to choose from one of these if you want to set up something, as well as you need to define the type of object. Like the pod here is the most basic object in Kubernetes API. Replica set is higher up the hierarchy of the pod, and it allows more features like scaling. Deployment is even higher, so it allows rolling upgrades and other features. Services allow connections between various objects in the outside world. Volumes allow to store the data, and so on and so on. So all of these objects have their own specific features you need to find out before you even deploy anything. And even worse is that, for instance, the volume can go various types. You can have like host paths, some local volumes, some persistent volumes. So again, it's a very huge choice in objects, which can be very confusing in the beginning. And on top of that, it's an API, so we can extend it, and there is a possibility to create custom objects. So you may ask a question, if we have such a rich ecosystem, why we would want to use custom objects? And basically, it allows us to build more obviously custom features, and it helps with Spark actually a lot and with various databases because we can deploy them with specific custom options we want to use. So Kubernetes operator, and we are going to talk later about Spark and Kubernetes operator, it's more like a paradigm or approach which allows to deploy our applications in a specific manner. So on the left side, you can see that we want to deploy some PostgreSQL database, and we define some deployment or stateful set, we define volume, service, and stuff like that. And then we need to think a lot how we would manage a state, whether it should be some custom automation workflow or anything like that. With operator, we just run kubectl apply on the YAML file. The Postgres operator is getting created, and deployment or stateful set is spawned by itself just from the operator definition, just because by default it's set up to be created as well as volume and service, and the data is stored in etcd. So everything is managed for you, but it's not completely automatic. So you can intervene a lot. You can change a lot of things, even in YAML definitions. So it's like a huge leap from going from completely manual approach to this more automatic one. And as I said, it really helps with Spark. So Spark Kubernetes operator has these four main parts, and it has controllers. So Kubernetes has this feature of declarative nature. It's like when we define the definition, when we define the YAML file with our application, it's our desired state of the system. Like we want to have this application, this number of instances, doesn't matter which one. But controllers should make sure that we have this set of instances in reality with all the parameters we set up. And for that, we would use a Spark pod monitor, which communicates a lot with controllers and just monitors basically some pod states, whether they change or not. Submission runner here is more like a connection between Spark world and Kubernetes world, and mutating admission webhook basically allows to inject various configurations or data if we need to do that on the go. So let's look at this schema, which would help to understand better how we run Spark application on top of Kubernetes. And you can see here that there are both Spark concepts and Kubernetes again. So we have Spark application definition here in our YAML file. We run kubectl on it and some Spark application object template create. It's not physical representation yet, not the actual object in Kubernetes. This template is sent to the API server the same way it's sent for any object in Kubernetes, just to check up whether the formatting is right, whether we used the proper API version, proper object type, and all of that. After that, the API server connects to controller, and controller now can check our desired state, which is Spark application. And submission runner gets into the play by running Spark submit. In Spark submit is one of the essential utilities to actually submit Spark applications to the cluster to set up all the parameters like master, executors, drivers, all of that. And as soon as the Spark application is submitted, driver is getting created, and then the driver is actually a pod in Kubernetes infrastructure. Driver asks for executors. They are both getting scheduled as well. And now we have 3 pods running, which are actually in Spark way are driver and 2 executors. And the events from these pods, like whether they are running, whether they are just terminated, got some errors, are getting into Spark pod monitor. And Spark pod monitor connects to controller. And in case something changes, like we have something broken or our driver didn't start up or we have only one executor, all of that is supposed to be managed and checked up with controller. So in case something is wrong, we would have to schedule more pods. And the role of webhook here is to inject some configurations like for login, utilities, monitoring, and some volumes for data storage. And it happens in such a way that even before the driver is created as a pod, webhook injects the config map, for instance, into our pod. And when our driver is getting scheduled, it already has some configuration we set up, some volume. So this feature actually exists only in Spark Kubernetes operator, not in the native support. So that is why it's very helpful to use operator, because we can define these config maps, volumes, although this time native support has become a bit better. So how it started for me? As I said, I was working at this huge consulting company, and it was an R&D department, and there were like various projects in big data and data science, and there were research projects as well as production level projects for clients. So at that time, I was working with graph databases like Neo4j or NDB, and we decided that it would be fun to actually deploy databases on top of Kubernetes. So I tried that, and that was the first time I encountered Kubernetes and started to work with that closely. And then we were thinking how we can actually apply it to the whole department and get some value in terms of projects from the client. So we were thinking that we need to build something internally. Like we all have some expertise in Spark, Kafka, all the other big data tools. And there was one person who even had experience with Kubernetes in production for a few years. So we were thinking that we need to build some kind of proof of concept kind of project with running Spark applications on Kubernetes. And we decided for Spark and Kubernetes specifically just because we heard about the news about Kubernetes native support The operator just was a few months old, like very fresh. So we were very excited to try out all these new things. And we started up with documentation, which is a pretty obvious step. And that's how our stories basically started, stories of our world with big data world and Kubernetes world. So documentation of Spark, actually even now you can check up on the latest release, has the whole section of running Spark applications on Kubernetes because again, it's natively supported. And that's where we started. So in order to run the very basic application, you can use some bash script launch with Spark submit or YAML file launch, which is more Kubernetes style because usually you operate with YAML file definitions and not bash scripts. So we tried running bash script first, and it worked. You just had to create, well, obviously we had a setup before of the operator itself, like building it from sources or creating, using the Helm package from the Helm package manager, setting up the operator itself, all the security, role-based access, and only then we could use this bash script with master defined as Kubernetes something host port, cluster mode, and Spark application is running in Kubernetes locally. But it's in cluster mode already. And another approach, for some reason, didn't work at that time. So what happened? You can see here the setup for Spark driver, which is the pod in Kubernetes ecosystem. And we can see that it goes from pending to init error state. And it's very not cool state in terms of it wasn't running the pod itself. So we don't have logs to check upon. Like if it would be in running state and then some crash loop backup error, then we would be able to check the logs, like what happened. But in this case, it was very hard to debug. And actually the cause was that custom object I got updated. And here for operator and for Spark app as well, we use custom objects. So that was happened. Actually, it happened a lot on our way of research, just again, because the operator library itself was very, very fresh, only in alpha version. So there were a lot of changes. And solution at that time was removing restart policy line. And right now I'm going to show how actually Spark app looks in YAML file. So you can see here a set of Spark specific features and Kubernetes specific features. Like section with metadata is just Kubernetes part like name, namespace. Also, you can see, again, alpha version for API. The kind of object is Spark application just because it's custom object. Usually you can see pod in this line, like kind pod, kind deployment. And in spec, we have a whole set of Spark related options like type of your application, the image you use, the main class, the main application file. All of that you usually set up with Spark submit. So it can be defined in such a way with YAML file custom object. And there is also another section for driver and executor. We have this core setup, which is very basic in this case. Only one executor, but we can set up as many as we need. And here it is, the offending line, which at that point didn't work. It was, by the way, temporary fix because later it worked using restart policy. You could use restart policy never. So in case your application fails, it never restarts. Or you can use always. So it means that your application will restart. And at that time, we just removed the line. It worked well, but later we added it back. So it was all right later. Another story was connected to Docker images. In Kubernetes, you use a lot of Docker images. And we used Google Cloud Platform image, which was kind of official one. And at some point, while using Spark Operator, something happened and it just wasn't working. And you can see Spark Operator pod itself, not Spark application again, Spark Operator pod, got from continue creating to at state, which again means no logs for us. But also, we debugged a lot and found out that it's actually connected only to the image version. So the problem was outdated Docker image version, and it was outdated again because of the fast pace of changes at that time. So it wasn't even reflected in any way by the documentation, by the wrapper we were using for the operator. So we didn't know whether the image version was like the newest we were using. And solution was, yeah, basically Docker image upgrade. But also this problem opens up the whole set of other issues we had on the way, and they were connected with how we stored our images. We used Docker Hub a lot because there were a lot of issues with using images locally, like pre-built Docker images locally. And also, I think another great solution would be to use Artifactory and actually move to it later on the project stage. So another story is connected to creating pipelines. Playing with Spark application is fun, but we wanted to build more like a pipeline, something more feasible. And we decided that we need to run integration tests on our Spark application. And how can we do that in Kubernetes? So we wanted to build some kind of a watch on our driver pod. So in Scala code, we would just check the state of the pod, like, is it running already? If our driver is up and running,
Hey, Roksolana. Unfortunately, we seem to have lost your sound.
can you hear me now?
Yep, we can hear you now.
Yeah, for some reason it disappeared. Okay, so using this library, we tried to build this pipeline, this test, and it was a very good choice for us because although it was an official supported for JVM, not specifically for Scala, so it was kind of painful for debugging in your mind the code from Java to Scala, the compiling it and rewriting. But anyway, it wasn't very good because the set of features was very limited. So the cost basically was limited first. And how we solved it, we just kind of changed the library. So in this case, again, the choice, the solution would be just more detailed research on the topic, like are there any competitors in the market, are any possible better solutions? And I'm pointing out to discussion because basically we knew about other libraries which were, well, not officially supported, but still were like a great choice. But we decided that, oh, we already built some functionality with this library, why we switch to another one? So we didn't switch in the beginning, but later we did, and it actually solved all of our problems. So another library we switched to was Fabricate.io or Kubernetes OpenShift Java client, which works with Kubernetes as well as OpenShift, but we used only Kubernetes functionalities. And it really has a great DSL and API features which help us to build the pipeline with patches, as I said before. So we built it. We were able to monitor pod states. We were able to run our tests on top of them, purge everything just as I said, and build this kind of testing framework even with the help of this library. And also we were able to do even more cool features, like we would parse the config file, then we would just generate a config map out of it, and then mount it directly into Spark application. So we create specific configurations, merge them into our Spark applications, and all in the Scala code without like specific usage of bash scripts or kubectl. So another story is connected to tests as well, but it's a bit different aspect. So we have this resources feature, and in order to actually check statuses of pods, you need to track their status kind of object, which is a sub-resource for Kubernetes. So using the library, which was the first choice of ours, didn't help us, and we saw that the issue was in the library, but actually it was in the REST API itself. So even reaching it through the REST API calls didn't help, and you can see here that Kubernetes has a straightforward API with a version, namespace, which is default, Spark application name, and status object. So it didn't help, and we actually found out that it was a Spark operator internal bug. So we were not the only one with this issue. Actually, the solution was just adding sub-resources and statuses section to Spark operator CRD, which is kind of a source YAML file of our operator. And that's how it looks like. You can see here the custom resource definition of Spark operator. And we added this section, this sub-resources and status. So with the help of that, you can follow on any status of the pod. And basically, it wasn't a very great solution because we ran all of our tests locally in this research stage. And it meant that every time we restarted our cluster, local cluster, I mean, or just even restarting your machine, you had to remember that you need to restart your operator and redefine this section, which was not, again, very good because you just have to remember it all the time. So it still was like the performance from the media solving this issue. So the lessons learned from this part. That thorough research, first of all, is very important, and even more important to discuss the results of your research with your colleagues and teammates, because sometimes they can give you even a better view on what's happening and give you some ideas on how to address that even. Also, another very, very obvious lesson is reading documentation carefully, especially using something completely new. And at that time, we had a lot of issues with even starting our basic Spark application, is the one story I shared, because we just read the documentation diagonally, like, I can see everything, I will do that, just easy. Turns out that you have to set up some specific role-based access, service accounts for Kubernetes, so it wasn't that easy. And another, I think, is that community is everything, and Kubernetes and both Scala have very great communities, and all our problems, which I shared, were actually solved with the help of contributors of Spark operator. So we just opened issues, got replies from them, got replies from contributors, people just having the same issues and trying to find various solutions. So it was very interesting experience in terms of community effort. So what happened next? We built this internal project, everything was going well, we felt pretty confident that there's a set of people in the department who are knowledgeable about running big data applications on top of Kubernetes. But something went wrong. Like, we didn't expect what was coming, definitely. So we had an opportunity to work on one of the projects. One was a long-term for some IoT services, and another one was very short, just only 6 months for the financial institution. And that was the project I took part in, and it started before the long term. So that was like the first project we tried our internal research results. So again, we felt pretty confident, but we didn't have the experience of running data on Kubernetes in production, only in some research activities. So it was totally different experience. Plus, we couldn't rely on any cloud providers because of the GDPR and security issues. This financial institution wanted to run Kubernetes and all the infrastructure on their bare metal servers, which was a very great challenge for the whole team, both DevOps infrastructure and the data team, because we had to set up everything properly on their bare metal by ourselves without relying on any cloud providers. So obviously the first story is connected to the expertise. Again, as I told, we had only one person with a few years of experience with Kubernetes, and he helped us a lot with building architecture, setting up everything, and educating the whole team. But one person is not enough. So we had a lot of issues on the way, like how we build this, how we build that. And I think that the biggest problem was lack of expertise with the bridge between big data and Kubernetes. Because like the data team had enough experience with the data stack, DevOps team had some experience with Kubernetes, so it was just hard to map them all together. And one of the consequences was that the ICD creation took a few months instead of a few weeks, as it was planned before, and it was like not very good in terms of deadlines. Also, the solution here would be like constant discussions and great team education, in my opinion, because we didn't have some specific like guidelines on how to work. We just worked on the project and had to really educate ourselves. We could ask each other, but we didn't have like specific, I don't know, sessions or any like, internal education just to move this project faster. So discussions here would be more helpful. Another story is connected to logging and monitoring. And as we were building the application in production, we wanted to gather some metrics and logs. So we decided to use built-in functionality of Spark Operator for log4j file. We just define the same way as in Spark Submit Java options for driver, executor. You can define various of them, like the JVM itself. And there is this log4j configuration, which is the path to log4j file in the container itself. So we worked around it, but for some reason the log4j configuration was not picked up. So we even debugged to the class loaders level to find out that this log4j file just can't be found in the container by Spark application for some reason. So we built kind of a temporary solution, which was just generating a config map, again in Scala code, as I told before, out of log4j file, mounting it into a Spark custom object, and then log4j file got picked up as config map, as well as other data which we mapped into it using volumes. So again, not all of the functionalities of Spark Operator itself were working at that time. So another story is connected to the infrastructure support. Basically, building any kind of infrastructure is a challenge for the whole DevOps and data team as well. And the data infrastructure on top of Kubernetes is even more challenging. And I'm talking more about Spark, but we had other tools like Hive, Roksolana for querying SQL data. We had the database, and the biggest challenge was with HDFS or Hadoop distributed file system. We needed to set it up in a high availability mode, which was very hard. And again, we were working with bare metal servers, so everything had to be set up on Kubernetes manually with manual workflows and upgrades and scaling. So I think one of the issues on the way was a shared development cluster. Unfortunately, we didn't have like role-based access to it, so our development team, infrastructure team, and the development team of the client could access the cluster without any kind of, well, it was authentication, but we'll be able to check who actually did some changes on the cluster. Maybe someone like broke something. And one of the consequences was data loss, but it wasn't production data, it was task data. But anyway, it could happen to production data as well. And constant infrastructure changes. So for big data engineering was like very bad obstacle because it couldn't, sorry? For big data engineers, it was an obstacle in terms of that you just come to work, try to build a pipeline or run a job and check it on the cluster, but the cluster just doesn't work. And some HDFS got broken or something happened again. And it was happening like very frequently. By frequently, I mean almost every few days, something was wrong with the cluster because infrastructure was very fresh and new, and there were constant changes. So it was very hard to work with it. And I think the solution here would be agreement about policies, like setting up properly role-based access so everyone would know what changes produce some errors, because it's better for observability of software, like defining whether something like that is going to happen again, and we never knew that. And also like checking out what actually triggered some issues. Plus agreements like inside of the team who can have access somewhere is also a great one. So the lessons learned from this part were that it's important to keep in mind challenges related to not only Spark, but overall tech stack you use, like whether it's Kubernetes and big data, then you need to keep in mind which things would be harder to set up. Maybe you just can use some cloud provider and it's going to be easier for you. Plus, it's important to make sure that there's enough expertise of actually development of the project. So if one person can solve it all, you can rely at least on a few people who would educate the team or build some specific pipelines for that so that people with less experience would have more time to learn and educate themselves, while others would do like more daily work. And another, like last but not least, is communication is key. And again, just having meetings may be very tedious for engineers, but having more like productive and educative meetings is actually helping a lot, and I'm pretty sure that a lot of people experienced it, to move the project faster and to understand where we are at this stage. So what was the result overall? Actually, expertise was developed in the department. So we all had like more knowledge on how to build the data applications on top of Kubernetes, and it was quite a few people. Plus, as I said before, the long-term project starting out already, like right in parallel with the one I was working at. So they could build their expertise from ours, like from our experience and our mistakes. Unfortunately, the project I worked at missed most of the deadlines, but it was delivered eventually, just later than expected. And again, the long-term project is pretty successful still. It's been running for a few years. So I think that all our effort for internal project and for the one like production level project was like worthwhile because it influenced in a very positive way on the next projects created in this department. And yeah, lots of sleepless nights because actually most of engineers, including me, we just worked with Kubernetes for a few months before this project started. So we had to grasp a lot of concepts, and for me, the most complex ones were again connected to the bridge between Spark and Kubernetes. I had issues trying to understand, like when it's Spark side, when it's Kubernetes side, how to fix various issues which you obviously see for the first time. So it was very challenging. But what I'm trying to say is that building the data infrastructure on top of Kubernetes feels and it is very challenging, but it doesn't mean you have to give up because it's fun. Actually, it's a very unique experience which helps to gain a lot in terms of knowledge, in terms of communication and everything I've shared already. And here are a few resources which you can use to start out. First of all, it's Spark documentation for running Spark applications on Kubernetes. It's already updated to Spark version 2.45 even, with even more features. Like right now, you can even mount volumes, I think, through bash scripts, not only YAML files. And also there is Kubernetes documentation. This one is a constant source of references. When you work with Kubernetes, you have to constantly check like features of various objects you want to use, their types, and all of that. So it's not only for starting out. Another my personal recommendation is the book by Kelsey Hightower called Kubernetes Up and Running, and it goes from very basic to more advanced concepts, and it helps to understand Kubernetes better specifically. And the last one is more like a fiction book called Project Phoenix. It's very popular in DevOps environment, as far as I've heard. It's more like a fiction story of a guy trying to manage the project, but it's more of infrastructure side and engineering side connected. So it's very fun to read. And here is the link to Spark Kubernetes Creating Wrapper. You can later see it also in the slides, which I'm sharing. Again, it's the one we used a lot to set up the project itself, to set up the operator. We opened a lot of issues there, and it's actively developed. So we started with alpha version, which was somewhere around to the end of 2018. Yeah, and right now it's already in beta 2, so it has much more features. And also here are the links for Java Kubernetes client, official library, which you can try kind of look at, but it's not very good. Fabricate.io is definitely fun to play with. You can run any, not only Spark, but even Scala application on top of Kubernetes. You can check it out and play with. And although it has like source code in Java, but I think it's kind of readable to compile it into Scala. And here's my Twitter, GitHub, LinkedIn, and the last one is Speaker Deck, and you can find there these slides and the slides of my other talks. And thank you for attention. I'm ready to hear your questions and to answer them.
Thanks very much, Roksolana. That was great.
Thank you.
So I have a few questions. For anybody who has questions, why don't you? To be honest, there are so few of us that I think that you could probably just speak aloud. But I'm going to go with my one first. So, you know, in a lot of your stories, particularly your first story, a lot of the problems that you were talking about were mainly due to the fact that something went wrong, but there wasn't a lot of diagnostics around what happened. So maybe there were no logs because there was something that went wrong on startup, or there was a REST API call and you didn't get the response that you expected, but potentially that wasn't logged either. Do you think that that's because you were doing something that was so new, or is it something that's just more systemic in DevOps, that often when something happens, you just don't have that information?
Actually, it's a very good question. I didn't think about it, but I think some of the cases were definitely because of the new tools. Like they were very, very fresh. But also, as I worked more with other DevOps tools related like Jenkins and just got more and more into DevOps side, I noticed a lot that there are like things you just try to start to think like whether it's magic, how you can even find out what's wrong. You just get from some experience with that, and over time you get to see more and more solutions to such issues.
Yeah, I've found that too, that it's, and maybe it's because I don't have enough experience with it, but it's very different to your functional programming kind of sandbox where ideally you call a function and the thing that you get back has some enumerated error, which is very clear. In my experience of especially with setup in DevOps, when you're trying something new, I have found that I'm not quite sure where to look for that information, maybe, or if that information isn't even there. It's interesting that you say that sometimes it's a bit magical.
Okay, I think, as you said, for engineers, it's very not straightforward because we expect just some response or at least some error or something, and sometimes have to wrap your head around it and trying to understand why it doesn't work.
Okay. Any other questions? Okay, I think everyone's still puzzling through your talk. So I actually oh yeah. So we got just a statement from Rodrigo that he uses Spark on Kubernetes at work, and the lack of documentation makes things a bit difficult. Did you find that as well, Roksolana? That there wasn't much documentation out there?
Actually, as I said, that there is one section of like native support, but it's only one section in Kubernetes with like very general approach and how to just run a simple Spark application, some explanation how it works, and that's it. And I think a lot of stuff actually you get to understand why it doesn't work when you get to understand Kubernetes better, which is more on DevOps side again. So I think that over time we get to work better with everything just because we moved more to DevOps every year. And again, like I said about issues with CI/CD, just because it was more like a communication issue for big data engineers to understand better DevOps side and DevOps engineers understand big data side.
Yeah, I found with to some degree with the documentation, like you said, the stuff that you find often on the official sites is usually very simple, almost like you're setting up a textbook thing with Kubernetes. Um, the useful information. Oh, I think that was just me speaking over myself, possibly. The useful information I found, at least that goes in depth, is usually in blog posts and potentially even in videos or conferences. Which is interesting that it means that it's more the community putting content out there that's raising its, I suppose, making it easier for other people to do the same thing as opposed to the official documentation.
Yeah, actually, the reason I made this talk is just to combine all of the kind of failures and the fact that we have this for people to start running Spark applications in Kubernetes and understand like that's where they start out and that's how we can solve it. Because we didn't have this kind of compilation kind of for the topics we have.
I'm having a little bit of trouble hearing you. I wonder if it's a microphone problem.
Yeah, there is echo.
Roxalana, do you think you could repeat your answer? Sorry, we had a little bit of trouble hearing you.
Yeah, okay, maybe it's the connection disappeared for a while. So I meant that I created this talk basically just to compile all these stories with failures and successes for people who start out. And even though right now it got updated, there are still some issues which were not solved in the upgrade itself. So I think it would be like a source of reference for people working with Spark Kubernetes and trying to understand how we can actually solve these issues as well.
And thank you very much for it. Hopefully, it will mean that whoever's trying to do the same thing can just go and look here and then get all the resources.
Yeah.
Cool. Okay. Well, thank you very much. I think it's now time to start with Adam. So.
Okay. Do you maybe want to make? Okay, now I'm back with video. Yeah. Do you want to make a short break, like 3 minutes, maybe?
Yeah, sure. Let's do. Why don't we do around 10 minutes, and let's rejoin at around 8.
Okay.
Reconvene.
Yeah. So everybody's more or less fresh.
Yes, that'd be great.